So we have our circle drawn with a radius of 15. Let's make sure that's right on 15. And we have our sector drawn, and our sector angle, as you can see up here, is 40 degrees. Here's another way we can write it. The measure of arc AC on circle BA equals 40 degrees. So first we want to do is find the area of this sector. And we know that the area of that sector is going to be the fraction, equal to the fraction that 40 degrees is of 360. So let's calculate that. So 40 divided by 360. So that's the fraction that sector is, or that angle is. So we have to multiply that by our area. So times pi times our radius squared. And our radius is 15. So there is our area, 78 and 5/10 centimeters squared approximately. Now we need to find the area of this triangle so we can subtract it from the area of the sector. So the first thing we need to do is find the height. So we need to draw in the height. So let's draw in the perpendicular line to the base. So there that is. And let's even show the intersection point so I can clearly see where my height is. So my height is from this point here to here. And I know that this angle in here is 20 degrees, half of the 40, because this is an isosceles triangle. AB is a radius and BC is a radius. So this right in here, let's see, I did have a caption for that. It's not there anymore. Let's see, there we go. Oh, just need one of them. So that's 20 degrees. This here is just a unit point, so I can hide that. That helps me adjust the scale, which I don't need to do. So going back to find the height, I'm going to use the trig ratio of cosine. So cosine of 20 degrees would equal the height over the hypotenuse, and that will help me find this height right here. So let's write that in. To find the height, I'm going to use cosine of 20 degrees, and that's going to equal the height over my radius. So I don't need that quite that big. Let's reduce that to 18, and we'll put everything in black that I'm calculating right now. So that's what I'm going to calculate. So I'll go up here to calculate and choose my cosine function, cosine of 20 degrees, and I want to multiply that by, so let's put the 15 in front. 15 times the cosine of 20 degrees, and there's my answer. So my height is equal to 14 1/10. Now to find my base. I know the radius is 15, so I know this side. I've just calculated the height at 14.1. I can find the base using Pythagoras. So finding the base, I'm going to use square root function. The square root of 15 squared, subtract 14.1 squared, and there's my base, approximately 5 1/10. The area of the triangle is going to be a half of this, half of the base times the height. So I'll calculate that. So half, 0.5 times the base, right there, times my height. So I have the area of the triangle, approximately 36 centimeters squared. It should be less than the area of the sector, and it is. All I have left to do is to find the area of the segment right in here. Would be to take area of the sector, subtract area of the triangle, and I'll have my answer. So area of the sector, subtract area of the triangle, there's my answer. So the area of that segment is approximately 42 5/10 centimeters squared.